Hello everybody and welcome back to Spacedock. I'm Hyperion and today we'll be covering the interstellar spaceships that do things the old-fashioned way, without using any of that newfangled faster-than-light stuff. I mean going the long way round, using propellant and lots of time. Even using hand-wavy tech to fly at near light speed, it's still going to take years to go to the closest stars. And that goes up to decades or centuries when using achievable technology for the task. There's many things to consider with trip times that long, and we'll get to those, but let's stick with the journey itself for now. Obviously, going faster reduces travel time, but accelerating up that far requires an extraordinary amount of energy, so you need incredibly efficient engine tech to even consider it. And getting closer to light speed means it takes more and more energy to accelerate, eventually reaching infinity to hit light speed itself. But even beyond the insane challenges of creating such a spacecraft, there's a number of physical peculiarities that stem from the hard limit that is the speed of light. These oddities, described by relativity, are why objects moving at high percentages of light speed are deemed relativistic. The biggest oddity is time dilation, a difference in time experienced between objects moving at different relative velocities. The faster you travel, the slower time passes for you, right up to stopping completely at light speed itself. It sounds crazy, but it's a real thing that's had to be accounted for in GPS satellites. Since they're orbiting the Earth at many thousands of meters per second, the time they experience is very slightly slower than what we have on the surface, which needs to be accounted for due to the entire system relying on extremely precise clocks. For an interstellar example, the ISV Venture star going to Alpha Centauri 4.4 light-years away takes 14.5 years to make the journey to an outside observer, but to those aboard it takes just under 6 years. Weird, right? It also means that if you never stop accelerating, you can reach the edge of the visible universe and come back within a human lifetime. Sure, there's some minor downsides like 10 billion years passing and needing a magic engine to do it, but it's theoretically possible. Another fun thing is that due to the way the complicated math works out, someone moving at 70% of light speed is really moving at functional light speed. To them, it seems like they're crossing the equivalent of 1 light year per year, even though they're going 30% slower than that. Yeah, it's odd. As is the view you'd see out of the window due to relativistic aberration, which is like the fancy spaceship version of driving into snow or rain. If you're stationary, the snow falls straight down, but the faster you go forward, the more horizontal the snow seems to get. On a spaceship, what happens is the view smushes down in front of you as you get faster and faster. It starts off pretty subtly at first, but when you get up to good fractions of light speed, suddenly it seems like the entire universe is in front of you. On top of that, you have the Doppler effect, which is just like the sound version we've all experienced. So we get blue shifted light where the wavelengths are being squished in front of the ship, and red shifting behind where the wavelengths are being stretched out. But this applies to all of the electromagnetic spectrum, so some invisible things become visible and visible things become invisible. I highly recommend you play with this visualizer tool made by Dmitry Lavros to experience it yourself. It's very cool. No matter whether you go slow or try to go fast, the design of your spacecraft has to accommodate a long journey. You need supplies for multiple years of travel that would take up a prohibitive amount of volume and mass, so it would be better to have a system that makes new supplies as it goes and recycle as much as possible. This is pretty easy for air and water and very doable for food. You wouldn't use meat though, because it's just far too energy intensive to farm. I'm not sure if even vat-grown meat would be comparable to the efficiency of plants, and efficiency is the name of the game when it has to last potentially decades. One way to reduce the amount of supplies you need is to make use of stasis. Whether it's freezing, hibernation, or being temporarily dead, I think we're all pretty familiar with seeing these systems aboard fictional spacecraft, even those that have FTL systems for those extra long journeys. Sci-fi also affords us some other, more exotic ways of storing people for interstellar travel, like not having any living crew at all. Instead, the passengers take the form of frozen embryos raised by robots in artificial wombs after arrival, but then And what are people raised by machines going to be like? Mind uploads are another no-crew option that can also be combined with the previous one. That way the embryos may be raised by people inhabiting machines, though if you have mind upload tech, do you also have the inverse capability to download into empty cloned bodies? If you don't have any of this, you just have to live through the journey. But for slower interstellar craft, that journey could last longer than a human lifespan, even taking into account time dilation, meaning the descendants of the crew will live aboard the ship too. These are generation ships, and they have a set of unique challenges all to themselves. How do you recruit people for a journey they will never see the destination of? And you need to think of a way to ensure that later generations never stray from their duties. The ship needs to be looked after, emergencies seen off, and the eventual colonization at the end has its own needs. The skills and procedures for all of these need to be passed down between generations with an emphasis on how vitally important they are. And these skills really are that valuable when you rely on a machine to make breathable air for you. Systems working for an extended period of time break down, which is less of a concern for relativistic craft that spend single-digit years of subjective time between stars, but for slower things, it's a massive concern. Machines that do ventilation, the aforementioned air scrubbers, water recyclers, centrifuges for gravity, things like this that are vital for survival need to be built to last potentially hundreds of years. Even basic stuff like power generators to run everything, because you can't use solar power. All those systems need to be monitored, maintained, and repaired with an almost religious fervor, which is why there's likely to be a crew for even stasis ships. To be fair, this role can be passed off to sufficiently advanced AI and robots, which does also avoid the need for supplies and maybe the degrading mental health of the crew. Imagine being stuck in the blackness of space in a confined area where your life relies on machines functioning for unprecedented periods of time. Just living through that is sure to cause psychological harm. This is possibly less of a problem for a generation ship where everyone is awake and able to support each other, but for a small crew watching over a stasis ship, there's a much bigger risk. So it's a good idea to have them work on a years-long shift system so everyone has a reachable endpoint to their shift that's not unreasonably far away. Internal hazards are not the only concern. Space isn't really empty, even out in the interstellar void. It is mostly vacuum, but there's still some particles of the simpler elements like hydrogen floating about, and maybe even a rare larger molecule, and when you're flying along at relativistic speeds, these suddenly become a problem. These larger particles pose a significant hazard since they hit with the force of weapons fire, but thankfully they are rare and you can intercept them with things like large-scale Whipple shields. While larger particles are certainly a concern, they are at least vanishingly rare. The smaller stuff permeates the interstellar medium more evenly, so an interstellar ship will be colliding with them constantly. And you know what else has relativistic particles? A particle beam weapon. So it's like constantly flying down the barrel of one of those for the entire journey, albeit a less concentrated one. To protect against this, you need a shield to absorb the impact and to eat the resulting spray of radiation. Rather than one of those big round plate designs, you could try laser sweeping the area in front, or have a magnetic or electrostatic bumper, or just go for an aerodynamically shaped vessel to make use of armor angling. As a bonus, pointy spike ships also look faster. This is what the light huggers in Revelation Space do, with the added protection of cometary ice cladding that gets eroded over time and thus needs occasional replenishment. So whether you attempt to cross the vast distances between stars quickly or slowly, there's a whole lot of hazards and unique design challenges to take into account. Either way, a trip is going to take several years at best, so it's no surprise that ships like this are rare to see, with fiction instead opting to use FTL to jet around. But that misses out on the great story opportunities that come with being set on an interstellar vessel on a lonely voyage between the stars. You can support Spacedock by joining our Patreon, where you can get our frigate and spacefighter design reference books. Alternatively, you can support us directly through YouTube by becoming a channel member. Thanks to our supporters, and thank you for watching.